right, so we left off here after having interpreted the mean as an expected value. And this is a more powerful concept than I think I really can get into. This is the foundation of choice theory, the beginning of economics. I mean, this is really powerful, heady stuff. Namely, that the mean is the weighted average of the values. The weights are the probabilities. The mean is the expected value. It is what you expect to occur in any system. Doesn't mean that it's going to happen. It means that it's what you're expecting. In gambling or betting, a game or decision or situation in which the expected value of the profit is zero. Does everybody see that? Zero. No gain, no loss is commonly called a fair game. So, for example, when you go to a casino, the most fair game, well, one of the most fair games you can do is craps, straight craps. Straight craps and blackjack are two of the fairest games you can have. All right, so I don't have the time or the inclination in this video to get into this. It is really a big deal. This is the beginnings of game theory, choice theory, which has its tentacles in, what stocks we buy, what spaghetti sauce we buy, and so on. I have a link here to an excellent video that's very short. It's a TED Talk about namely the expectation and how expected values are supposed to work a certain way and how we often don't use them the way that we should and make poor choices and so on. And it's excellent, and I highly recommend watching it. All right, now here we go to suppose a life insurance policy sells a $250,000 one-year term life insurance. I'm gonna get Excel here. Hold on one sec. Poof, like magic. Here it is. All right, so they sell you a life insurance policy of $250,000 for a 20-year-old male for $450. According to the National Vital Statistics Report, Volume 53, Number 6, the probability the male will survive the year is 0.998611. Compute and interpret the expected value. See that? When they ask you for that, they're really asking you for the mean of the insurance policy to the company. Okay, so let's figure out the profit. In other words, let me do this. Gain and loss. Now, who gets the gain and who gets the loss kind of depends on whose side you're on. For this particular thing, they said to think about it for the company. So the company is $450 to the good if this guy lives through the year, right? Let me insert this just a second. So if the guy lives, the company gets $450. If the guy dies, then they are out. Now, I know you think it's $250, but it's not. It's $250,000. Take away the $450 right there, right? Because they still got the $450. So when they give you the $250,000, your $450 still counts into it. It doesn't seem like much, and it's not. But for a company that's selling lots of policies, it will matter. Now, what are the chances this guy lives? That's 0.998611. What are the chances he dies? Well, you either live or you die, right? So it's equal to 1 minus, not times, minus that value. It's the complement rule from chapter 5, right? That they have to add up to 1. Okay, so now we need the mean. Well, the first thing we need to do is to gain times probability. Okay, because the gain is really your x value. Let me put it this way. Right, that's your random variable, how much you gain or lose. Now, there's only one bad thing about this, and I'm sorry to say, I didn't do it right, so bear with me. When you lose in accounting, that's negative, right? So I'm going to give it a negative value. It's negative 249,550, and this is positive. Okay, so I multiply my x value times my probability, and I do it again for the other one, and then I add them up. And that right there is the mean, i.e. expectation. We expect to make $102.75 on this policy. Oops, cancel. We expect to make $102.75 for each of these policies if you're the company. So if you sell 100 of them, you make $1,000. All right? Oh, that'd be 10 of them, excuse me. So multiply by whatever number.